All right, solving systems of equations. Hopefully this is a little bit of review. You have done this before, but we'll see. So, a system of linear equations is when two or more linear equations are working together. Okay, and a linear equation just means that we don't have any like squared terms in there. We just have like an x and a y or just two variables, okay? And there are different types of solutions that you can have here. A solution is like what makes these, where they're crossing, because linear means that they're lines, and so it's where they're crossing. So you can either have no solution, one solution, or infinitely many solutions. And let's just talk about this for a second. So here, when there is no solution, that just means that the lines, your linear lines, are parallel, which means they are never going to cross, right? One solution means that they cross at only one point. And lines will only ever cross. They'll never cross, or they'll cross at one point, or there will be infinite solutions, which means that this is just the same exact line right on top of itself. Okay, so let's go through how to solve these. So if we have this, and we're gonna solve them three different ways. We're gonna solve them by graphing, we're going to solve them by substitution, and we're going to solve them by elimination. So we're gonna do graphing first. So we have y equals negative 7x minus 1. We have y equals x minus 9. So these are in the form of mx plus b, where m is the slope and b is the y-intercept. Okay, so if we look at this one, so y equals negative 7x minus 1. Well, m in this case is negative 7, and b in this case is negative 1. So that means that the slope is negative 7, and we could just put that over 1 because that helps us see like, oh, we go down 7 and then we go to the right 1. And then the y-intercept is negative 1. So I'm just going to go down to negative 1, and I'm going to plot that point right there. And then the slope, remember, slope is rise over run. And so I always go to the right. Always go to the right, and then if it's negative, I go down, and if it's positive, you go up. So this is negative 7, so I'm going to go down 7, and I'm going to go right 1, which gives us a point right there. From those 2 points, we can graph a line. Okay, so there is the graph, or the line, y equals negative 7x minus 1. And let's do another one. Let's do the other one. Y equals x minus 9. Well, now this has a m of 1, because if there's not a number in front of here, remember, we can always just assume that this is a 1. And then a y-intercept of negative 9, or the b value equals negative 9. So that means that our slope is 1 over 1. What's happening? Our slope is 1 over 1, and the y-intercept is negative 9. And so that means for the slope, I'm going to go up 1 to the right 1, and the y-intercept, I'm just going to cross the y-axis at negative 9. So if I go down to negative 9, there's my point. Then I'm going to go up 1 over 1. There's that point, up 1 over 1. Notice there's the same point right there, right? And so then there is that line. Which from looking at this, we can figure out what this solution is. It's where these two lines cross, which is right there. One solution, which is right there. So that's going to be 1, negative 8. Okay, let's do another one. So y equals 5/2 x plus 2, and y equals 5/2 x plus 4. Well, if we graph the 5/2 x plus 2, that means we have a slope of 5/2 and a y-intercept of 2. This one, 5/2 x plus 4, we have a slope of 5/2 and a y-intercept of 4, which means that we have the same slope here, right? I don't know why I put this on here. Women when they wear the same shirt, men when they wear the same shirt. Now, that is not true for everyone. I have friends who we, have worn the same stuff before and we don't fight. But anyways, okay, so let's graph the top one. So the purple one has a y-intercept of 2, so it's going to go up there to 2. And a slope of 5/2. So that means I'm going to go up 5 and I'm going to go over to the right 2. So that's that point right there. And I'm going to do the same thing with the blue line. So it has a y-intercept of 4 and a slope of 5/2. So I'm going to go up 5 over 2 right there. And then we have that line. And notice these lines have the same slope, which means that they are parallel, which means they are never going to cross. So they're parallel lines. There's no solution there. Okay? Now let's solve by substitution. So I use substitution when it is very clear, one of your variables is solved for. So then we could just take this and we could plug it in down here. When there's already a variable solved for, that's when I decide to use substitution. So if we use substitution here, I'm going to take that y variable and I'm going to plug it in for y in the second equation. So that's going to look like 7x plus 3, and then this negative 5x plus 30 just replaced this y, which is why it got put in right there. Okay, and that equals 42. And now we just have to solve this equation. So someone right now is making this face trying to solve a math problem. Always. Unless they're using PhotoMath, which please stop using PhotoMath. It is driving me absolutely bonkers. Okay. You can distribute that 3 in and you get negative 15x plus 90, and then the 7x and the 42. 7x minus 15x combines to be negative 8x plus 90 equals 42. Subtract the 90 over and you get negative 8x equals negative 48. Divide by negative 8 and you get x equals 6. And we are not done at this point. So we have solved for the x value, but we need to solve for the y value because remember our solution is a point. So now I need to take that and I'm going to plug it back into one of the top equations. Okay, and I'm going to plug it into the equation that is already solved for y. So then that's going to be y equals negative 5 times 6 plus 30. So I took this and I plugged it in up here. Okay, which negative 5 times 6 is negative 30. So that's negative 30 plus 30, which is 0. Cool. So that means that we have one solution at 6, 0. So these two lines, if we were to graph them, they're going to cross at the point 1, 2, 3, 4, 5, 6. They cross right here. I don't know exactly what these lines look like. Like this one of them looks like this, and the other one probably looks like this. Okay. All right, let's do another one. So this one, we're still going to solve it using substitution. I would maybe use elimination, but that's okay. So I'm going to solve that top equation for x by adding the 7y over. And then I'm going to take that and I'm going to plug it into the x on the bottom. So that's going to be negative 4 times 7y plus 53 minus 5y equals negative 19, or equals positive 19, sorry. Then distribute that negative 4 in, so you get negative 28y minus 212 minus 5y equals 19. Combine on the left to get negative 33y minus 212 equals 19. Add that 212 over and you get negative 33y equals 231. Divide by negative 33 and you get y equals negative 7. That is the first part of our solution. Remember, we need to get our ordered pair here. So then to get the second part, I'm going to take that and I'm going to plug it back into one of those top equations. And I'm going to use the equation that's already solved for x. Okay, you could plug it into either one of these ones also, and you'll get the same answer. This one is just already solved for x, so it makes it a little bit easier. So then 7 times negative 7, that's negative 49, plus 53, which will be positive 4. So then again, we have one solution, and it's at 4, comma, negative 7. So that means that our lines here, we have a line that looks something like this probably, and they're crossing at 4, negative 7. Oh, that's not what our line would look like. So if we have 4, negative 7, so that's like somewhere in here. So we have a line that's going through that, and we have another line that's probably going like this. Okay. Next, please. So now we're going to use elimination. Now, elimination is very important because once we get to 3 variable equations, you have to use elimination, okay? And notice here that the 2y's are opposite of each other. So like 2y and negative 2y, we could just add these 2 equations right off the bat and they'll cancel. Oh, here's just like a little, let's talk through this elimination thing over here. So we have life plus love equals happy, and life minus love equals sad. Now, I'm not saying love is everything, but, well, so see how we can eliminate the love. So love is gone out of our lives. Well, life plus life equals 2 life, and happy plus sad equals happy plus sad. And then if you divide it by 2, you get half of happy and half of sad, and that's real life. Kind of true. Life has a lot of ups and downs. Anyways, so back to our math problem here. So those 2y's can cancel the way that those loves canceled. So I can just cancel. I'm going to add these together, and those 2y's cancel out right there. And I end up with 8x equals 64. And then I can just divide by 8, and I get x equals 8. Now, same thing as we were doing on those other ones, we need to take that and we need to plug it back into one of the top equations. I'm just going to use the top. So 3 times 8 plus 2y equals 22. So that's going to be 24 plus 2y equals 22. Subtract that 24 and you get 2y equals negative 2. So y equals negative 1. Which means we only have one solution here, and it's 8 comma negative 1. Let's do this one. So 3x plus 2y equals negative 21. X plus 10y equals 21. Now we need to decide which variable to eliminate here. And I'm guessing I decided to eliminate the x's. You can eliminate the x or the y. It does not matter. But to eliminate the x's, they need to be opposite signs. So that's why I'm multiplying this equation here by negative 3. Because then that's going to give me a negative 3x right there. So if we multiply that by negative 3, you multiply the entire thing by negative 3. You end up getting negative 3x minus 30y equals negative 63. So now I'm just going to rewrite those right next to each other. So we have 3x plus 2y equals negative 21. Negative 3x minus 30y equals negative 63. Those 3x's cancel, and I'm left with negative 28y equals negative 84. Divide by that negative 28, and I get y equals 3. Now I'm going to take that, and I'm going to plug it back into one of the top equations. So I have x plus 10 times 3 equals 21. So I took this, and I plugged it back into that equation right there. Which x plus 10 times 3, well, 10 times 3 is 30. So that's x plus 30 equals 21. Subtract that 30, and I get x equals negative 9. So again, we have one solution at negative 9, 3. Okay. Let's do this last one. So 4x plus 7y equals 12. Negative 3x plus 4y equals negative 9. Now, this one is not super obvious which one to eliminate, so I'm just going to choose to eliminate my x's again by multiplying that top equation by 3 and the bottom equation by 4. Because, so, since they didn't have, like, something, like 3 didn't go into 4 and 4 didn't go into 3, well, if I take this and I multiply it by 4, I end up getting negative 12x. If I take this and multiply it by 3, I get positive 12x, which then those will end up canceling. So then if we multiply that top by 3, I get 12x plus 21y equals 36. If I multiply the bottom by 4, I get negative 12x plus 16y equals negative 36. So I'm just going to rewrite those. And then the x's cancel here, leaving me with 37y equals 0. Now, I don't know why this is such a struggle, but when you have something like 37y equals 0, the answer is not like y equals 37. We have to divide. So what this is saying is 37 times some number equals 0. Well, 37 times what is going to give us 0? It is 0. That is the only thing that's going to give us 0. So in this case, you can just divide by 37, and you end up getting y equals 0. Now I'm going to take that, plug it back into one of those top equations. So I have 4x plus 7 times 0 equals 12, which is 4x plus 0 equals 12. So 4x equals 12, which means x equals 3. Again, we have one solution at 3, 0. Cool? That's all. Okay, bye guys.